welcome to another edition of Cosmos with Cosmos. As always, I'm Mike.
I'm Liz.
I'm Brandon.
And today, we're talking primordial black holes.
Ooh.
Also known as brain-melting quantum stuff.
Yes. Prepare to have your brains melted if
Ugh.
you listen or watch this
There's
episode.
so much pressure. Today's episode is brought to you by the Big Bang.
The Big Bang!
Without it, you cannot have primordial black holes. You also could not have cosmos. So, Brandon, what are you drinking today?
Oh, I had a whole. Oh, so I am drinking. Quark's Anti-Era, which is vodka, splash of orange liqueur, sparkling water, and cranberry mango juice.
Ooh,
nice.
I almost did a vodka cranberry because I was like, I don't know, part of me was like feeling a little vodka cranberry-ish, but
You could have done it.
I
Could've
did
done it.
not.
We have all the
that.
ingredients, which is 2.
Yeah, pretty much, yeah.
What you drinking?
I am drinking, that's a good question. Because this episode might leave you with more questions and not knowing what the fuck is going on.
I see here I did that. Okay.
Like that?
that was good. That was a good twist.
And it's basically a margarita with lemon juice and a galaxy syrup.
Now, we did lemon juice because we had no lime juice.
Yeah, we didn't have any lime juice, so it has lemon juice. But still pretty good.
Yeah, so tequila, lemon juice, galaxy syrup, and triple sec. And that one. So, giving that a nice little orange flavor to it.
Yeah, it's good. It's got a nice little fruit kick. I got a little bit of tequila, which I've enjoyed more recently. So, yeah, what do you got?
I have what I'm calling magnetic monopoles, just because it's such a weird topic. But anyway, it's very like gray looking, and
here, I'm gonna hold it up to the camera.
All right. So it has
sparkles in it.
It has white rum, Jamaican rum, a pineapple dragon fruit juice with the galaxy syrup that we got just yesterday. We're like, it had us at Galaxy.
The Galaxy.
We were like, we got to try this.
And it's not very milky.
No, not milky at all.
It's more Andromeda-y.
Yeah.
And like with yours, it has a little bit of glitter in it. So
you put glitter in mine too?
Yeah.
Now I see it.
I chose a pink glitter because I thought it's rainbow. I did not choose the pink. I chose rainbow because I thought maybe
it looks like just purple and blue basically.
It might show up on the blue background, but
Jack has a dirty strawberry Italian soda, and I want to know what makes it dirty, Jack. That's what I want to know. And Katie has water, which is a good, smart, healthy choice.
Isn't dirty just a combination of different types of soda?
Is that? I don't know, because I like to get a dirty vanilla chai, and the dirty is espresso.
But here in Utah, I think the dirty just means different types of soda.
That's that weird Utah thing where they have soda shops and they just
it's everywhere.
There's
so many.
Everywhere.
Like the other day, I was driving down the street and a soda shop was just littered with the youths. So many youths.
It'd be so much better. You just add a little vodka in this or a little bourbon in these, But I get it, Utah.
Yeah. Yeah.
Good for the youths going to those soda shops.
All right, follow us in all the things. We have.
It's dirty because of 2 shots of almond milk. Oh,
nut milk.
we like that dirty nut milk.
Jesus, my brain immediately went with just like middle school brain with dirty strawberry Italian, and then you add the nut milk later.
Gotta add those nuts.
Anyway, follow us in all the things.
Yeah.
Drinking Cosmos at Twitter. Cosmos everywhere else. Yeah. And follow us and rate us on wherever you get your podcast. Like and subscribe. Give us a thumbs up. Also, add comments or something. It really helps the algorithm or whatever it is that the young kids are saying today. So anyway, do all that stuff and help us out. Don't forget that after this, we have okay. Don't forget right after the main episode here, we have the Hangover, which we're gonna talk about. What are we talking about?
Artemis II.
Artemis II around the
Why?
moon
Did
and
that
splashing
happen?
down.
Did that happen this week?
The biggest joke in history happened on April Fool's this year.
Yeah.
Apparently. No,
Right.
we're gonna talk Artemis 2. I got some pictures that I'm gonna pull up from Artemis 2. But I recommend Googling them yourself because they'll probably look better on your own monitors and shit.
But
we're gonna talk
just
about
hang
it.
out and you'll be able to see those. Hang out for the hangover. And
Yes.
and then you'll be able to see all that. We have some friends of the pod. That they're friends.
Yeah.
You know,
So
family.
these are some Nepo sponsors.
Nepo sponsors. Check out Wildixia. Wild IXIA on Etsy for some really cool art, and buy stuff. Buy the damn art.
Buy stuff.
Yeah,
Buy stuff.
Also,
Participate in capitalism.
yes, right. I'm a socialist, but damn it.
It's a small business. It's a small artist.
Yes.
Small. Yeah, you can get it.
Also check out the Mr. Proctor show. I always want to add Ron. The Mr. Proctor show. For Easter, I noticed that he did a cool Blender tutorial on him and Waylena.
Yeah, and a Planetarium colleague. They did a
Waylena.
Yeah.
And they did the Easter eggs. So,
Mm-hmm.
also, if you happen to be in the Council Bluffs, Iowa, which is in the southwest corner of Iowa, check out Rolling Bluffs Planetarium. And our friend Jack will show you the universe at Rolling Bluffs Planetarium. Check out more information about what Jack has going on at rollingbluffsplanetarium.com.
Woo!
Also, every other Wednesday is the shot. Do we have to record a shot?
I'll look at the calendar.
Look at the calendar. Anyway, these, because it won't be today. Anyway, these are just short, in theory, 10-minute long, little, nuggets of astronomy that, it's fun to listen to. And actually, we've had a lot of fun actually making them. And I think Brandon said that he likes doing it more than he likes doing this show. So
I like all my children equally.
Yeah, you have to
but some are more equal than others.
Yes. When was the last shot that Brandon did?
Listen, I've been putting out fires.
I think he did one last time.
No, he didn't.
I did not.
No, I get the
didn't
whole.
communicate it in a timely manner. That was my bad.
I get the whole I love some of my kids more than others. I will let my kids figure out which ones.
If you want his love, watch the show.
it's like laying a knife down on the table and saying, "Go." Good luck.
Also, as always, we have a few rules. Star Wars reference or a Lord of the Rings reference. Please take a drink.
Forget.
Sweet.
All right.
That's the show. See you next time.
Yeah.
Right.
That's all there is to it.
That took like 12 minutes.
Let's get primordial.
Primordial black holes. So
let's do regular black holes first.
Oh, we gotta understand regular black holes before we can understand.
Did you not read the notes?
I didn't read a single bit of the outline.
She's going in blind.
And that's how I want to do it. I want to be amazed
really quick,
and
I think it was last episode, The High in the Sky, there was a moment about a news article talking about primordial black holes, and I had not heard about those because it's kind of a recent development in the world of science. And we go,
but now we have some actual possible evidence for them for the first time.
Okay.
Yes.
Basically, I saw a paper came out last year, so.
Yeah, I did an article on The High in the Sky, which we had the wrong image up for this live stream for it. My bad. And that's what spawned this episode, was a deeper dive into.
Yeah, I saw the reaction from Brandon. Just like, what the hell are these things? What? This is a thing?
Uh-huh.
And I was like, wait a minute, but you had not heard of them either.
No. But add primordial to anything, and I'm in. Let's do it. I love a good primordial soup, primordial black hole, primordial ooze, primordials.
Primordial. All right. Okay. Well, first, as you guys all know, I do like black holes, and so I jumped at doing this. But anyway, just a real quick reminder of what a black hole is.
Sure.
It is a region of space where the gravity is so strong that once you fall into it, you cannot escape.
Yeah, goodbye.
Yeah. Basically, even light cannot escape it, so that's why we call it a black hole. Looks
Could
like
Superman
it'd be
escape it?
what?
Could Superman escape it?
Well, I mean, he is Superman, right?
I'm
He's
sure
gonna
there's
go
some lore
fast.
out there.
Yeah, right. We'll have to consult the lore on that. But there's really only.
Oh, what about the Flash? He's the fastest one, right?
Yeah, but he still can't go faster than the speed of light.
He actually can.
Oh,
He
shit.
can?
Technically, according to the canon, he can go faster than light.
Oh, okay, he's a
Then
tachyon.
maybe he's a tachyon.
Yep. All right. Well, I would have to disagree with the physics on that, but anyway, whatever. Sometimes you just let it go, right? Yep. Oh, take a drink.
Yeah, that was Solana brings a motion reference.
All right. Anyway, there's only 3 properties that define a black hole.
Yeah.
Its mass,
Mhm.
its spin, and its electrical charge. Those are the
Simple.
only 3 things.
Simple object.
Easy.
It is.
Yet one of the most mind-melting.
It is
Big hole.
a black hole is the simplest object in the universe. As of now.
Spaghetti-
As of right now,
It's
our
spaghetti-
understanding of
It
physics.
spaghettifies my mind just thinking about it.
String theory might just blow that shit out of the water, but you know, whatever. So how were these guys made? Well, you know, in today's universe, if you have a really massive star, something that is about 8 times the mass of the sun, at the end of its life, it will go boom, big boom.
Big bang
And
boom.
that big boom is called a supernova explosion. And what results from it is a black hole. So in today's universe, black holes are created from the death of stars.
Yeah.
And Brandon, deliver it.
But they were all of them deceived, for another black hole was made.
And that is the primordial black hole. Primordial black holes were not made by the collapse of stars.
No stars, because there were
There-
stars.
Yes, because they were
That
made
took a while.
when there were no stars. So we'll get in.
Yeah.
We'll get into.
Because the thing about the current black holes and stars is that the star has so much mass that that gravity just keeps compressing and compressing and collapsing down until it's nothing but that single mathematical point, and then it's
right. So
can't go any
in
further.
a regular star.
So you need to have a lot of mass.
Yeah.
To have a
so
black hole.
you have this. You have competing forces inside of a star.
Yeah.
You have gravity that wants to pull it in. Hold on. You have radiation that wants to blow it apart. And what is that called, Liz?
Hydrostatic equilibrium.
Hey!
Yeah.
But the radiation pressure that keeps it afloat, keeps it puffed out, is created in the core of the star
from all that
nuclear fusion, right? Well, and the star kind of runs out of that fuel, and it's not able to do any nuclear fusion anymore. Radiation pressure goes away.
Lose that equilibrium.
Yes, and gravity is always wanting to pull in.
It wins always, doesn't it?
It wins.
Generally?
Gravity will always win. You might leave Earth and head to the moon, but you're still being pulled by gravity.
I don't know. I got a magnet that stays pretty good.
We don't know how those work.
Jesus is pushing it.
Oh, okay.
Radiation pressure goes away. Gravity makes it collapse, and then it rebounds off the core. Boom! That's the explosion, and then the core becomes a black hole. You can also get neutron stars out of supernova
depending on the
explosions
mass of the star, and it's
So these are not primordial black holes. Are not created from stars. They are created really kind of from the Big Bang ghosts.
Big Bang ghosts.
So, and the Big Bang didn't actually create it, but it was shortly after the Big Bang. And in the notes, I had just written a Big Bang detour because I was just going to talk about the Big Bang just real briefly. And Brandon, I sat down at the computer to work on notes today.
Did the detour turn into its own little road trip?
And Brandon's going on full on road trip. Yeah, he's got it all mapped out, all these places.
We're going to the Great Ball of Yarn. We're going to the tallest
Absolutely.
cowboy boot. We're going to
But there's a reason for that, because I'm not, a fancy physics punk at all. I kind of see things visually through a narrative. So I needed to get an idea of how and when these black holes came to existence. So I needed to see the field around it, right? Not just a single point and talk about the point, but the Big Bang itself, what happened directly after that, and kind of go chapter by chapter until we get to these primordial black holes. And I go, oh, that makes more sense now.
Yeah. And so I was really only going to, so the Big Bang, after the Big Bang, the history of the universe, like the geological period on Earth, is broken up into epochs and eras. And I was really just going to talk about one of them, and that was going to be it. And Brandon just goes into quantum physics and all of that. And I'm like, we're doing this.
All right, let's do it.
Buckle in, everybody. Hold on to your butts.
So, Brandon started this whole thing by saying, fun fact, there are 7 eras of the universe within the first 3 minutes of its existence, which is true. And most of these are just exceedingly short, mind-numbing short.
Be a fly in the universe.
Yeah. So, since Brandon brought it up in the notes, at least tangentially, well, he did a few of them. I'm like, we're including all of them.
I'm sorry, great use of vocabulary word right there, tangentially. Very nice.
Oh, thank you. I don't think it necessarily applied, but
I like it.
I use big words.
I like it. Some of those officious. I'm sorry.
That's an inside joke for us. All
Sorry,
right.
I'm sorry. Apologies. That was for me.
So the very first epic in the history of the universe is the Planck epic, the Planck era, and it's also like the shortest. It is 10 to the minus 43 seconds.
Wait.
After the Big Bang.
After the Big Bang.
Wait, but modern physics can only understand 10 to the negative 32 seconds after the Big Bang. We
actually can get pretty close. Yeah. So
wait, is 10 to the 42 bigger than 10 to the 32? I don't know what.
We can with modern physics.
Yeah.
We can get down to 10 to the minus 43 seconds after the Big Bang.
It is minus 43. Okay, it must have changed.
Beyond that's
the wall.
That is the wall to physics right now. We do not have unlike, I don't know, I'm just gonna pick a word, and I'm just gonna say, unlike creationist, it's just a word I made up, that can't admit that they don't know something.
Right.
In physics, and in science,
they go,
we can.
We don't fucking know.
And this is the wall. We beyond this, we don't really understand.
Yeah.
That is really short. You cannot. It's so hard to conceive 10 to the minus 43.
Yeah, because it's like
it is a 0 point
and then
43 zeros.
Yeah.
And then you might have a 1.
Yeah, it's like such a. Yeah, I'm already dead. I'm already dying. I'm already done.
And so that's.
And it's just amazing that we have figured out how the universe operates up until that point.
Yeah.
Now, there are real fundamental questions that do not allow us to get beyond that wall. Like, how does gravity really fit into all of this? That's the main one. And then once we can break through that wall and make that understanding.
Like the Kool-Aid man. Just send the Kool-Aid man in.
Yeah.
Get him a degree in physics.
Yeah. And there's some ideas out there, like string theory.
Right.
But string theory.
Which is more of a string philosophy.
It's more of a philosophy because at this point right now, you can't test string theory in the way that you would want to test string theory. And if you can't test it, it becomes a philosophy. But we're going to be able to test it at some point. And if it's correct,
it's a Mike George promise.
I might not be alive, but
we will be
we
able to test.
Reading my lips.
We will break that. Mr. Physics, tear down that wall.
Damn.
That's like a deep cut to the 80s guy. Or 90s or 80s. It was 80s.
It's within our
It was
demographic.
Reagan. It was Reagan. All right. So from 10 to the minus 43 seconds to the 10 to the minus 36 seconds, you have what's called the grand unification era.
Grand
Or the
unification.
guts. The gut
era.
era.
This is
Oh.
where and by the way, in the Planck era,
Mhm.
all the laws of physics, all the forces of physics are
They're
unified.
one. They're one.
They are one.
They're one.
But
They're a single force.
I saw an interesting, and the universe is in symmetry. But I saw an interesting description of the symmetry, and it's like a pencil that is standing upright, but on the point.
Right. Okay.
And so it's in symmetry,
it's
but that
tedious.
symmetry is not going
It's-
to last.
Yeah, okay.
And well, because there's 43 zeros and the 1 in time, I can get a pencil to do the same thing in that amount of time.
Yeah.
That's true. That's true. All right. So the universe expands.
Mhm.
Gravity falls off. It is
Oh.
now not unified.
Oh
It is now not unified
no.
with the other forces of nature, and there are 3 other forces.
So it was first to leave. It was like, fuck
It
you
was the
guys.
first to leave. So
Going out on my own.
the 4 fundamental forces of gravity
Yes.
of the universe
Yes.
of physics
Gravity.
are gravity, strong
Strong.
force,
Weak force.
weak force, and electromagnetism.
Oh, okay.
So in our everyday world, we experience the electromagnetic force,
Light and heat.
light, heat, friction,
Magnets.
magnets, all of that kind of stuff. It allows me to touch you without touching you. And gravity, those are the 2 forces. But on the nuclear level, down at the
You got the strong
quantum
weaks.
level, you have the strong and weak
Mm.
force.
Mm.
The strong force is what binds nuclei together.
So it holds us together.
It's like the force, yeah.
It's the force.
Well, no. Electromagnetism holds us together.
That was a Star Wars.
Strong
I know.
force, the strong.
It's a lot of force. The Force Awakens.
Oh, do we have to do another one?
Nope.
All right.
Nope. We'll leave it to that.
The strong force holds the nucleus together.
Okay.
And it has a certain range in which it operates,
Right.
and that range will basically dictate the maximum size of a nucleus you can get. That is why a periodic table looks the way that it does and doesn't have like 1,000 other elements on it.
Oh, okay. Okay. Yes.
The weak
Yes.
force also works at the quantum level, and it is responsible for like nuclear decay and stuff like that. And so, when for your small atoms, typically small nuclei, it's harder for them for the weak force to operate on them because the strong force is strong. But as you get these bigger nuclei, is able to really overcome the strong force, and that is why
The
you'll find
underdog
that.
wins.
And that's why you'll find at the bottom of the periodic table, a lot of that shit's radioactive.
Oh, because the weak.
The weak force is able to
Okay.
break it up a little bit.
Okay.
Yeah.
All right.
All
My
right.
brain's already done.
And each one of these forces has a particle associated with it. Electromagnetic, photon. With the weak force, W and Z bosons. With the strong force, a
Bosons.
gluon. And with the gravity, it is the hypothetical graviton.
Graviton.
Yeah.
And I love that he's not reading from notes. He just knows that off the top of his head.
He does. That's why he's fancy.
Nerd.
I know.
I love quantum physics so
I
much.
know. I know. He does.
I'm
God,
more of an Einstein guy myself.
You would love to be like Ant-Man, just so you could go down and
Oh,
the
God,
quantum
yeah.
worlds and
Yeah.
check that out, huh? Not necessarily Ant-Man per se, but that technology. You would take that Pym's technology.
All right, so from 10 to the minus 36 seconds after the Big Bang to 10 to the minus 32 seconds
Oh my
after the
God.
Big Bang.
Man, getting old.
Oh, man,
We're
we're
getting old.
We're getting close to a second here. Not really anyway.
Not
the
even
sh-
relatively.
The strong force pops off because I don't be with you guys no more.
Man.
Yeah, and so
It's
it
like
falls
Morgoth.
off. It
What?
falling off Wait a minute, what happened?
He said,
I said the strong force leaving the other forces is like Morgoth leaving the Iron Earth.
There you go. Yeah, that's deep cut.
that's
Lord of the Rings.
similarian.
Oh yeah, got that right over here.
Nice.
The strong force popping off causes something to happen to the universe. It is called inflation, and this is a rapid expansion of space-time. So much so rapid that it is faster than the speed of light. Now, I know.
Wait, there's no light yet.
I know. All of you guys out there, all you physics fans are like, wait a minute. Hey, Susanna.
That's exactly what they're
she
like.
heard the opening of the
Like,
show.
nobody sees chat in this part of the show, so it's just like a random.
So, for all you physics fans, I know you're gonna say, hey, Mike, hey, man, nothing can go faster than the speed of light.
So we got to sit down and talk about it,
Apparently
man.
the
You're going
Flash
crazy.
Yeah. That is true, generally. However, space-time can expand faster than the speed of light.
Yes.
And so, space-time is not limited by Einstein's speed limit.
Yeah, get out
Cosmological
of
speed
here.
Einstein hates this one simple trick.
Fucking.
So, what's crazy?
Yeah, check out our episode on time.
Yeah. Oh my, nice.
Thank you, Susanna.
So the universe goes from exceedingly small to the size of a grapefruit in that time. A little baby universe.
I can't.
I'm assuming that means like going from the size of an ant, we talked about that, man, to the size of the solar system. I'm assuming it's something in that scale.
Oh yeah, I think I would say that. I should have done like some sort of calculation like that.
Yeah, but you know,
and
you weren't expecting to go on this road trip down to the time of the Big Bang.
And it goes from, and this happens between 10 to the minus 36 and 10 to the minus 32 seconds.
I mean, it's like it's
so fast. And then so the universe at this point is this quark gluon plasma. There's a lot of quarks and gluons, the strong force particle that are just kind of interacting, and it's basically I think Brandon had mentioned at some point that it was a quark soup in his notes, and so
imagine all those Ferengis competing for business.
I know, right? And so at this point, the universe actually is cool enough to where that expansion can slow down, and we move on to what is now called the electroweak epoch, the electroweak era, and it goes from 10 to the minus 36 seconds. So this is kind of happening at the same time as inflation.
Yeah, this is happening real fast.
Yes, but it goes to 10 to the minus 12.
Now,
so a trillionth of a second.
A trillion.
Now wait a minute.
After
this electroweak is not one of the errors I saw. So for me, it goes straight from inflation to the next one, to quark.
Yeah.
I don't. That's interesting.
Yeah, you skipped a whole.
You skipped a whole epic.
A whole epic, man.
Which when I initially was reading epic is spelled EPOCH, and in my brain I always pronounced it as epoch until I heard somebody say it, and I was like, oh.
So this is when particle interactions create a lot of exotic particles. Kind of think of CERN with this. Yes.
Getting fancy out there.
You can think of CERN. CERN can make energies associated with this. Kind of. You hit these things.
Yes, we hate money inflation, but not universe inflation has been good for us. Well, maybe up until this point.
At this point, the W and Z bosons are created. This is the particle for the weak force. The Higgs boson and Higgs field / Higgs field is also created. This gives mass to particles. So now particles have mass, and now they slow down. They could not go faster than the speed of light at this point.
Oh, no.
In the next epoch is what Brandon had alluded to. This is the quark epoch. And this is from 10 to the minus 12 to 10 to the minus 6 seconds after the Big Bang.
All right, we'll
we're
get
just
into measurable
flying
time.
through these.
Are
Yep.
we?
These are quarks, are fermions, and in the notes, oh man, I deleted it by reading stuff. Brandon had mentioned that quarks have color, and he said, "Nope." I didn't know that.
They're flavors. They're flavors. Of quarks, right?
it's just not. It's
No,
a categorization.
the color is not associated with flavor.
Oh, okay.
Yeah, there are
They're not like Skittles.
right. It's what there's
That
6
tastes of the
quarks.
quark rainbow.
With quarks, you do have 6, and then in this epic, you probably did have those really massive ones. You have up and down, which is what is responsible for what we find in the world today. You have top, bottom, strange,
And weird. No.
strange and charmed.
Charmed.
And strange.
I don't know why. Charmed. Why do they call it charmed?
Because
Okay,
it's a
it's a different
semi-charmed kind of life.
It's or it's just witchy.
So, they have an attribute, a thing called color, and I think Murray Gell-Mann and all the other people who came up with what's called quantum chromodynamics, which is the theory behind all of this, they were doing some just crazy acid. They were doing
No,
acid.
they didn't need to do acid because physics was their acid. My brain is already melting. You don't need additional substances to get there.
So for quarks, the color has nothing to do with color that we associate with, that we understand.
I don't think it's big enough to have color yet.
That's true. Well, I mean, color really is
it's just the
our
wavelength
brain interpreting
Yeah.
energy. The wavelength or the frequency
what's absorbing or
of
emitting
a photon.
different.
Yeah, and so it's basically how these quarks, and the anti-quarks and stuff like that, actually interact with the strong force. So that's all it means. And there's red, green, blue, and then you have anti-red, anti-green, anti-blue. And so the reason why...
And none of this means actual colors of red, green, and blue.
Right. So, but these color combinations, what we're calling color here, have to be combined in such a way that the resulting color is neutral or white. And so with like if you have a proton which has 3 quarks in it.
Sure.
If the first 2 are red and green, the third one has to be blue.
Right.
Okay.
And so that makes white.
Because if you got another red, you're more red than you are.
Exactly.
Right.
Exactly.
Okay.
And so that actually limits the number of the particles that have 3 quarks, the number that you can have, or at least the configurations.
Right.
Now, you do have some hadrons or fermions, or the fermions that have 2 quarks in them, and
2 quarks this time. Boop.
And if you have one quark that is red, the other one has to be anti-red. It cannot be any other color. If it was anti-blue,
when you got a fascist, there's always an anti-fascist.
Yeah, right.
Ideally.
So that's the whole thing about the color. So I just love that Brandon put nope in there.
Nope.
All right. So during this time, the electromagnetic separates from the weak force, and so now we have all 4 forces that are.
This is gonna be a long episode. We haven't even touched on primordial matter.
We're gonna get there.
We're gonna get there.
We're not
explaining the environment.
We're not even through the 1 second of the universe's creation yet.
Well, now that you say 1 second, we get there with the hadron era. This goes from 10 to the minus 6 to 1 second. The universe cools down enough where protons and neutrons are actually made. And Brandon says there's this another anti-war between protons and antiprotons, and neutrons and antineutrons.
Because we didn't mention the cool thing in the quark era is that's when the matter and antimatter war happens. They all collide with each other and destroy each other, and there is more matter than antimatter. And so that's how we're here today. It's because matter won out.
Matter won.
Matter matters.
Matter.
Guys.
Thank you. Yes.
What did we just hear?
It was a Teams thing. It's a spam thing. It was not for your teams.
So from 1 second to 3 minutes is called the lepton era. This is when leptons or electrons actually dominate the universe. Electrons and positrons go to war, resulting in their destruction, which is the destruction is photons, which then go about making more electrons and anti-electrons or positrons. But there's
last merge of the positrons.
Yeah.
It is likely that we go to our dooms.
I can hear the music in my head. So obviously electrons went out, or the non-anti-leptons went out in this great battle. From 3 minutes to 20 minutes is the nucleosynthesis. This is when atomic nuclei start to form with hydrogen and helium. You also get a lithium.
A smattering. Just
a smattering of
lithium.
A sprinkle,
right
yes.
there. Yeah.
A salt bay worth of lithium.
The length of this period in the history of the universe is determined by two things. One is the cooling of the universe. So the universe gets big enough to where it cools. So as it expands, it's cooling.
Yes, yes.
And so it expands enough where it cools to where they just don't have the energy to combine. But also with nuclear fusion, you have to have neutrons. And neutrons, you have to have free neutrons. They got to be floating around. They can't be combined.
Tied down.
Yeah, they cannot be combined with a proton. So there's flying.
All these single neutrons.
Very hot single neutrons.
Yes.
If you like it, put a proton on it.
The half-life of a neutron, a free neutron by itself, is not stable. It will actually disintegrate into a proton, electron, and a neutrino.
And something as well that really wrinkles my brain at this point is you have the entire universe in a grapefruit bowling ball, Earth-sized object at this point. But because that's everything, it's still a shitload of gravity. But there's so much energy in the Big Bang, gravity is still losing its battle and it's expanding. There's so much energy in the Big Bang. Nope.
The nucleosynthesis period. And by the way, that is a description of a free neutron.
He's pointing to a tattoo he has.
Pointing to a tattoo.
For the podcast folks.
Yes. So there we go. Because I worked on that project. Or a project associated with it. It's about 13 minutes, half-life of a neutron. So that's why this period only lasts 20 minutes. That's it. And the temperature, by the way, it started this is about 1 billion degrees.
1 billion degrees.
From 3 minutes to 240,000 years, gradual cooling. The universe is filled with photons and a plasma of nuclei and leptons. The universe is dominated by these photons.
This is a big stretch of time. We went from just fractions of a second to now from 3 minutes on to 240,000 years.
But when there is only energy, what is time?
What is time? Check it out.
From 240,000 years to 300,000 years, so 60,000 years, is what is called the recombination. This is where the universe cools to around a temperature of about 5,500 degrees. Celsius, 5,500 degrees Celsius.
Federico's comment in chat is, we went from an era dominated by leptons to hadrons, from nucleons to photons to actually morons. Yes, we are in the moron epic.
Moron era.
The moron epic, at least in this little region of the universe.
Susanna, we'll get there. That'll be in the Hangover.
In the Hangover, we'll talk about the astronaut baddies.
In this period, electrons are captured. They're captured by the nuclei.
No! Free the electrons!
And so they are captured by hydrogen and helium nuclei. This is in physics terms called recombination, and the universe becomes transparent. This is the first time that you can actually see through the universe.
I mean,
a photon
mhm.
can now travel through the universe and never meet another particle, never
So lonely.
hit somebody's eyes,
Wow.
and that is the cosmic background radiation.
That's the cosmic background
Yes.
radiation. Okay.
And that is as far back
As
as we can see. Yes.
Okay.
The universe is the universe at this point is, like I said, about 10,000 degrees Fahrenheit, 5,500 degrees Celsius.
Oh, that's reasonable.
That's good.
At this point, though, at this point in the history of the universe has expanded so much that that the temperature is about 2 degrees above absolute zero. So the energy that those photons have
It's cooled down quite a bit from a
is
billion
cooled down
degrees.
quite a bit because of the expansion of the universe.
Right.
Then we go into what I think is actually the coolest
Yeah.
era, the Dark Ages.
There's always the Dark Ages.
They're
But literally.
there are literally no
Yeah.
stars.
That's just.
There's matter.
It's just-
There's photons
It's
that are
dark.
flying through
It's
the
just-
universe.
It's literally dark.
It's dark. There are no. You can't. If we were to be plopped down there, we would not be able to see anything.
It would be like. Yeah.
Now, speaking of dark and no stars, made me think of sound. So in the early universe, that less than 1 second, because there's so much stuff, there technically could be sound waves, right? Because there's enough stuff with everything.
Yeah.
The reverberations. You could hear the Big Bang.
Everywhere.
I mean, you would die.
You would die. You can't hear the Big Bang.
No.
there's
I'm
no
saying at that
bang.
point. I'm saying at that
Oh,
point
yeah.
at
Is there
T minus
sound?
negative 37
No,
seconds.
okay.
Well, it's still a vacuum.
Oh, back then?
It's a vacuum, but there's everything is together in a single location, so it's not necessarily a vacuum. Then there's so much stuff in it. Right?
Wait, are you talking about one of the previous eras, right?
Yeah, I'm talking. This is called inflationary, for example.
Yeah,
When
probably,
the universe,
Don't
yes, you
ask
could
these types
get-
of questions, Brandon.
You could get sound waves.
but your drink is called. That's a good question.
Yeah.
You could get
Okay.
quote unquote sound waves
But there's
That-
so much stuff. Yeah, but
that's
you would
flying
probably
through the universe now. But in the recombination, when it clears out, when
Right, it's not
things
so much.
are captured, electrons are captured, and the universe is big enough to where you don't have particles that are
Mhm.
bumping into each other, because that's really what sound is.
Yeah.
It's a compression wave.
Okay,
because-
so then it's just quiet and dark.
Yeah.
Quiet.
At this point, yes.
God, it
and
sounds
dark.
wonderful. It sounds like one of those sensory
Sensory
deprivation
deprivation tanks.
tanks, which
Yeah.
sounds amazing. By the way, Suzanne in chat says, "Wait, a galaxy is a group of stars, right?" Yes, and we're not even at stars yet. We haven't even.
So
No stars
from-
are around.
The
at
Dark
this point.
Ages go from 300,000 to 300,000 years to about 150 million years. 150 million years to about 1 billion years is a period called reionization. This is when the first quasars are formed. Quasars are basically supermassive, supermassive black holes. Matter is swirling around it and falling into it.
Wait! But you can't have the supermassive black holes without stars.
Listen, Liz, don't ask questions. He will find you.
God damn it!
We'll kind of get there. All right. Energy emitted by these quasars reionizes the surrounding universe. And so basically, all those atoms that work so hard to come together, quasars rip apart again. You know?
God.
So from 300 to 500 million years and beyond, stars and galaxies form. So this is when they are starting to form.
Let there be light.
Let there
phase of
be
the
light.
universe.
8.5 to 9 billion years after the Big Bang, a little cloud of dust and gas starts to fall in upon itself,
Is it us?
and it creates an average yellow star
It's a baby
in
solar
the outer
storm.
regions.
It's us.
In the outer regions
Above.
of just a normal spiral galaxy.
It's when we
In the
were-
boondocks.
And around that, hundreds of planetismals, and eventually 8 planets, 9 planets, and then 8 planets
It all
form.
went down.
But on the third planet, there is life.
Third rock from the sun.
Third rock from the sun.
Yeah.
Life eventually forms. And 13.8 billion years after the Big Bang, a podcast is created
Woo!
called Cosmos with Cosmos.
It's wild all that happened in just 7 days. You know?
Suzanne asked, who discovered this and how? A lot of people
Yes.
with a lot of
Yes.
science over many, many, many years.
Okay. So that was more in depth than I had originally intended, but I love getting
This is your
the
fault.
history of everything. I'll take acceptance of that because the episode is not about time or the history of our universe. It's about primordial black holes. So with that environment now known, so we go back and say, when did primordial black holes exist?
In inflation period. They think that
And inflation, by the way, was 10 to negative 30 seconds to 10 to negative 32 seconds.
Yeah.
That's when?
Yeah.
That short little time and you get primordial black holes in
Yeah.
that fucking time frame?
So now we can talk about the episode. Primordial black holes.
That little time frame is when,
Oh,
and
God, I
they're
didn't
still
drink.
here? Well, obviously they're still
So-
here.
So primordial black holes have been a thing in physics, a hypothesis since the 1970s.
Like I said, new.
Very good.
So 50 years.
All right.
Take a drink.
This is going to be my last drink.
I said very good year.
All right. So there was a Soviet physicist, Zeldovich. Wait a minute.
Sure. It's confidence. Confidence with those names.
Yeah, you actually had it in the notes. Yeah, Yakov Zeldovich. Him and
Say it like
Igor
you're drinking vodka.
Novikov.
I am.
They
Where is it?
came
Let me
up.
see it. Let me see it. Let me see it. Where is it?
They came up with the idea.
Where is it? Point it out to me.
Down in your notes somewhere.
Alright.
Primordial.
Yakov Zeldovich and Igor Novikov.
Why did we make this Italian?
Well, I didn't mean to use the Italian when I was doing the vodka accent. The Russian accent.
Anyway, in the 1960s
Apologies,
and
Federico.
70s, they came up with this idea where primordial black holes could have been formed
Mhm.
after the Big Bang that are not related to how black holes form.
Stellar
today.
mass black holes.
Stellar
But,
black holes.
Is there a why? Why they were like, hey, I think there was primordial black holes.
Oh, you know what? Oh, I didn't.
They just had too much vodka one day. They're like, hey,
Probably.
guys, what if there were black holes before there were black holes?
Probably. But basically what they said was that there were probably regions after the Big Bang where gravity, that the density was so great, the gravity was so strong that these black holes formed.
There's a high concentration of gravity.
High concentration of gravity and all that.
It's like you go to instead of an oxygen bar, a gravity bar.
Yes. Right. And so
Those are rooms.
Isn't that just a trampoline park?
yes, there are different types
Yeah.
of black holes.
It is.
So then the question becomes, okay, so scientists, scientists would love these kind of strange ideas like this, and they love them for two reasons.
Yeah, they do. Fucking weirdos.
They
It's
love
funding.
them. They love them because they can maybe run with them.
Could lead to a Nobel Prize.
Nobel-
not a
Nobel
Peace Prize.
Prize.
Just a
Yes.
Nobel.
Or they're like, we're gonna debunk this. We're gonna
Mhm.
prove it.
Mhm.
This can't happen.
Right.
And so primordial black holes have lasted over 50 years. So it's not like it has really gone away for something that doesn't have a lot of evidence behind it. But the Higgs boson also did not have a lot of evidence behind
and
it
then
for like
bam,
60 years
all of a sudden,
until.
CERN made some particles go together and was like, "Oh shit, guys, we
So-
did it."
So how you create these things is a real deep dive into physics. And
Deep end,
and it really
mind
is.
melting.
So you have things called axion inflation, which is axions are these particles that string theory says has to exist. String theory is a philosophy right now, and so it is. String hypothesis really is what it is to be called.
The string dream.
It's pretty stringy.
So, so that's really quite very hypothetical. All of this is really kind of hypothetical. You have this thing called reheating, which happens in the transition between inflation of the universe and the very next epoch or era, in which is kind of a radiation dominated
Right.
era.
Sometimes you just gotta put it back in the microwave.
Yeah, pretty much. So in this radiation era,
Mhm.
the universe is really trying to get into like a thermal equilibrium, but so everything's the same temperature.
Yeah, it likes things to be.
And if you look at the cosmic background radiation, pretty much everything really is at the same temperature.
Yeah.
But there's slight differences.
Tiny variations.
Those tiny variations is what leads to formations of galaxies and stars, and eventually us.
It's not completely homogeneous.
It's not exactly. Big science word.
I did it.
So maybe this process of getting into thermal equilibrium is not complete in some of these areas, and it becomes really dense, and you get primordial black holes that pop out of it. Also, another idea that maybe can create.
Wait. Okay.
Yeah.
I'm sorry. Okay, so basically you have.
God, this is like my favorite episode because brain melting.
Okay, so you have this concentration, a higher concentration of gravity, which means that it's pulling in more whatevers of particles, which makes things denser, and so those all come together because of the density and the gravity, and that's what makes the primordial black hole versus the stellar mass of gravity taking all of the mass of the star and compressing it into a black hole. It's just like a density of just this primordial soup of particles.
And did you already mention they're subsolar mass black holes?
Not yet. I was going to.
But I had to, because I don't think we actually, you clarified that it's the densities that come together and that gravity that then.
Right. So since primordial black holes are not beholden to the size of the star.
Yes.
Because there are no stars at this point. They can be any size. They can be.
But does size matter when the universe is the size of a grapefruit?
It does matter.
Because you have to have enough concentration of gravity to have that.
So yes. So because you're not beholden to the size of stars, you can have black holes, primordial black holes that are many orders of magnitude smaller than a centimeter, up to like basically, what we would consider stellar mass black holes.
Okay, so you can have real tiny.
You can have extremely tiny
ass black holes,
and this is why primordial black holes are so important. Because you can have these small primordial black holes. These are great candidates for dark matter.
Oh,
hell yeah! Now we're getting into it.
And so these become what we would call machos in massive,
take that, wimps,
compact halo objects. Machos. There's two types of dark matter.
Wimps is the weakly interacting
massive particles.
Yeah,
and that was disproven, right?
No, actually, there's more evidence for wimps than there are for machos.
Why are these fucking science nerds calling things machos and wimps? This is them projecting what they've experienced in high school, getting bullied, the machos versus the wimps.
Just real quick now. Just really quick before we get into this, you can also have cosmological phase transition, so end of inflation, or when one force pops off another, you can actually get these densities that make
which matters, because we'll talk about that later too.
Everything matters.
Unless you're antimatter.
Okay, question though. Okay, query. So, I used the wrong phrase the other day. Then what did I say?
Right.
Anyway, okay. So you're saying
inquiry.
I said inquiry.
Anyway.
The primordial black holes saying could be like dark matter. Okay, and I was thinking, could they also be responsible for then like galaxy formation and bringing? Okay.
So
all right.
These primordial black holes, if they were created now, become basically dark matter.
All right.
And
that's perfect because you can't see them.
You can't see them.
Can't fucking see them.
And they
They got no light to bend around them.
Right. So they become that structure that kind of that they help
Foundation?
build the structure. They help build the structure that we
Okay.
see. And the first, so you ask where the quasars come from. This
Yes.
might be an explanation for some of that.
Ooh.
And so you have these primordial black
So,
holes.
The universe is built on black holes.
If they're really small, we're going to get into the really small part in a minute. But if they're larger, they're going to attract more stuff, which is going to fall on it, which is going to make it bigger. That kind of stuff.
Yes, Brandon.
All right, so we have hypothetically all these primordial black holes swimming around the early universe at this point, and of course the universe is expanding, zipping around the galaxy. Yes, so all these primordial black holes zipping around the galaxies, even the universe, and the universe is expanding, and it's expanding the space between these objects. But how does the universe know when it's expanding from the size of a molecule to a grapefruit? What isn't like? Why aren't these particles and these black holes being expanded as well? Does that make sense?
For the same reason that galaxies aren't expanding
Yeah,
today,
but
gravity is still at work. Gravity and
never
forces
quits.
of nature
Never
are
quits.
still at work.
so if
Brain melting. His brain is melting.
if gravity is that strong, then to hold these objects together in this early universe,
gravity
my
is
question.
so much fucking stronger than
because
because the entire universe inside of a
It's
grapefruit.
smaller. Yeah.
Because physics changed. Well,
Oh
yes.
God, I had a question. I had. Okay, these primordial black holes, if they're the size of a fucking, what'd you say the smallest one? Prepare yourself. Look.
Yeah, they're smaller than a centimeter.
Okay, if they're smaller than a centimeter. Okay, hypothetically, if you get near one, do you still spaghettify?
No. All right. No.
Can I eat them?
Are they Skittles?
Okay.
Can we have
right,
black hole Skittle? Okay, all right. I'm sorry. Yes, I know. Let's.
I actually have like a whole section.
All right.
That's even like more like mind numbing.
I just want to eat a black hole now.
Anyway,
see what it does to my insides.
If all right,
yeah, for sure.
Yeah.
So what started all of this was 2 weeks ago. Liz
fucking chose an article randomly about primordial black holes being possibly seen for the first time. Well, not seen, but
right. No, it
seen.
Actually, potential evidence for
primordial black hole after all of this, after over 50 years of hypotheticals.
Yes. So on November 12th, 2025, the LIGO Virgo Cogra team reported on S251112 CM. This is a compact binary merger candidate, and it took place during the quark hadron transition era.
And really quick, if I may, I just want to read the first sentence in the abstract of that paper.
All right.
So I think Mike will enjoy this. I think everyone will. The detection of subsolar mass black holes is a milestone of modern astrophysics, as it would open a window either onto new stellar physics or could potentially unveil the nature of dark matter as primordial black holes.
Yes.
That's a hell of a sentence.
Mm-hmm.
So, when a stellar mass...
I do love me some stellar physics.
when a star becomes a black hole, there is a certain size that black hole can be. It's something like 3 times the mass of the sun or bigger.
Yeah.
And so when you find...
Otherwise, you're a neutron.
Otherwise, it's a neutron star. So when you find the merger of black holes...
Of something smaller.
Of something smaller than that, it's like...
What? No.
Either this is a primordial black hole or we got some new fucking physics going on.
Right.
Most likely it's primordial black hole.
Right.
And so that's why this is so big.
Right.
This is really the first time that we're seeing something like this.
I forget what in the article, what was it? What was used to? Oh, it was LIGO. It was LIGO. And what's great about this is that there are I forget what they're called. That's coming up. That's even more sensitive then LIGO, Lisa. Don't ask me what the acronym is. Do you know the
Laser
acronym?
interferometer space antenna.
Okay, so Lisa, God, I really hope like their imagery they should use like this Lisa from The Simpsons because she's like nerdy and smart and wonderful. Okay, so it's gonna be even more sensitive than, and LIGO's already so sensitive, like they have to cancel out like pickup trucks that drive by, like just normal shit that's driving on the road, far away from them, they have to cancel out. They have to eliminate as background noise basically. So Lisa being more sensitive, so the more sensitive we can get, then the easier it is to detect this kind of shit to then help prove the hypothesis of primordial black holes.
As long as NASA keeps it funded.
Okay,
Governments.
we don't need to fucking look. Let's just pretend.
Is LIGO NASA though?
No, it's ESA, but NASA is a huge contributor.
Yeah.
I didn't know LIGO was ESA.
So that would set it back quite a bit. Lisa, ESA.
So this is a big fucking deal.
It's a huge fucking deal.
This is a huge deal. And it's not that, okay, LIGO has two places. LIGO is in Washington State.
Yeah, we could go visit it and check it out.
Yes, and also in Louisiana. And so it's not like you see one and go, oh, that's it. That's it. You got to see it both places. And if you can bring in Virgo, which is Italian. Federico.
Hey, Federico!
Oh,
don't do that, Liz.
Man. I can't help myself.
Anyway, Virgo,
I'm
Kagra.
married in Italian, so I think I should be allowed.
Kagra is Japanese, and so if you have all three of these,
that's a fucking
that's a big
fucking
deal.
Good ass fucking.
So there are implications for this. Dark matter, galaxy formation, a thing called the cosmological domain wall, which
I've never heard of this.
Yes,
you have to change. You usually have to change, I think, group policy settings.
Yeah.
Is it past the paywall?
This arises from phase transitions or force breaking, things like that, in the early universe. It would actually imprint on the cosmic background radiation. We do not see that.
Oh.
So the question is why? Primordial black holes might be an answer to that. They could clump matter together and get rid of those domain walls. It also could the primordial black hole would have to be formed first in this case, and so it would actually prevent these walls from happening. If it was after the primordial black holes form after the walls form, maybe they played in some sort of role in getting rid of these walls that we don't see in the cosmic
We can
background.
call them Jericho black holes.
Yes.
Make the creationists happy.
Magnetic monopoles.
Hey!
Yes. My
Your
weird
drink.
colored drink. This was first mentioned.
Magnetic monopole. So mono is one, so it's a single pole.
So if
What?
you have a magnet, if you have a bar magnet,
Yeah,
okay, there's
you
a
got
north
yeah,
and a south,
yeah,
right?
Yeah.
If you cut it in half,
You got
there's a north and a south.
Yeah.
There's always a north and a south.
yeah.
However, Paul Dirac, a famous physicist back in the 1930s, he wrote a paper, and he said that it basically that if you had magnetic monopoles, you could if you had magnetic monopoles, you would have electric monopoles in the universe, and we have electric monopoles. Electrons, protons.
Because they're only one charge.
They're only one
each.
charge.
So you would either have a magnet that was a
So
a positive or a
if
negative
you have in a universe that has electrical monopoles, if that charge is quantized, if there is a minimum charge, which there is as an electron, all charge is based on the value of an electron and how much charge it has. Even protons are based on that. Then magnetic monopoles can only exist in the universe. So it doesn't mean that magnetic
of
monopoles
course.
exist. But if you do have
Then
quantized
they could. Or
charge, then they could. And so in modern quantum physics, magnetic monopoles should be there, right? However, when we look out in the universe, we don't see them. We don't see magnetic monopoles anywhere.
How would we even discern?
Well, it would have certain characteristics and
I
stuff
broke
like
now.
that.
I broke.
And so
Shutting down. Press reset.
Join the club. I've been here for a while.
Resetting now.
primordial black holes might actually answer that, where they absorbed the magnetic monopoles and stuff like that. So, and then string theory has all this shit that it talks about.
Fucking string theory.
Yeah.
It feels like primordial black holes are one of those theories, one of those ideas at the time, like from 100 years ago, could solve like half of physics, right?
Mm-hmm.
It's like, oh, if these existed in T minus 36 seconds after the Big Bang, it could solve all these problems.
Yeah, but we have a tantalizing piece of data that says they might exist.
Yeah.
With LIGO.
I mean, the fact of even trying to, even trying to find evidence of them requires such a specific, sensitive technology.
Right.
Because especially if you're dealing with a black hole that is on the I mean, look, the only way we even see stellar mass black holes today are the effects, the gravitational effects they have on all the visible matter surrounding them. So primordial black holes, if it's something that is even like as big as a fucking inch, a caterpillar or whatever, that's almost impossible to see with our current technology.
And how do we learn what happened in the quark era by a tiny vibration of a laser in Louisiana?
Yeah.
What the fuck?
Yeah, we're using lasers to fucking detect black hole collisions.
We should probably do an episode on LIGO.
We need to, yeah.
But it's crazy with physics that we can go all the way back to 10 to the minus 43 seconds after the Big Bang.
But we can't find out what girls are thinking.
But there's still mysteries. There's still mysteries with the physics that we do know. There's still mysteries that we're trying to answer. And LIGO obviously is a key player in trying to understand primordial black holes. We're going to hopefully launch the Nancy Grace Roman Space Telescope later this year, which is infrared space telescope, where part of its mission, scientific objective, is to look for primordial black holes. Ooh. Which is the way that it's doing it is to look for gravitational microlensing, a very specific signature with gravitational microlensing.
That seems difficult.
But these are oh my god. So many more questions.
The Fermi telescope has actually limited how big some of these can be. Primordial black holes with a mass of 10 to the 13. I'll get into that in a moment. Makes up less than 1% of dark matter. So it is basically put an upper limit on, at least for these particular 10 to the 13 kilograms. It also has said that it has basically excluded primordial mass black holes with a mass between 100 and 1,000 solar mass black holes. So we do have Fermi's not seeing them directly. The Fermi is a gamma ray telescope, or is it X-ray telescope? It's one of them.
I think it's
X-ray.
I think it's X-ray.
Because
it's not seeing them directly, but
you can't see any of them directly,
right? But it's saying because we're not seeing this particular signature in X-rays, they don't exist in this particular mass range.
Okay.
So I do want to say that black holes, the interesting thing that I did not mention about black holes at the top of the show 14 hours ago was that black holes have a lifetime.
Yeah, a long ass fucking lifetime, but this is where Hawking radiation comes in, right?
Yes, Hawking radiation. Stephen Hawking.
Thank you, Stephen Hawking. I've stepped on your grave, sir.
Predicted that. Well, he actually showed that black holes do not. They're not entirely black. They radiate energy. And right there, just above the event horizon, there's the curvature of space and time is so great that you will get little particle pairs that get created. And so a proton and an antiproton will get created. They go out and they're like, hey, I miss you. And they start to come back. In normal space, they annihilate each other.
Oh, no.
And the timeline for this is 10 to the minus 43 seconds.
Oh.
So
why couldn't it be 42?
Yeah, so it's called the Planck time. It all has to happen in that time length. But anyway, right there at the black hole, one of these particles, and these are what we call virtual particles, since they do not exist outside of that 10 to the minus 43.
So it's like Bitcoin.
It's like Bitcoin.
Oh, we don't talk about that.
They're not quote unquote real. They're real, but not in the way that we.
Yeah.
But if it's right there at the black hole, one of them falls into the black hole and the other one escapes. And at that moment, it becomes a real particle. It becomes Pinocchio.
It becomes a real boy.
Oh.
It becomes a real boy.
It's a Pinocchio particle.
Yes. And so to make the physics work, the one that goes out is a real particle that we can now interact with and we can say it's there. But the proton that falls in to the black hole it now has to have a negative mass. Mass 1 plus negative mass 1 equals 0. It has to always equal 0, right? And so it falls onto the black hole and takes a little bit of mass with it. And so
it
the
eventually
black hole
disintegrates the black hole.
Evaporates it.
Over trillions and trillions of years.
Well, it depends. And so the rate at which that radiation goes out from a black hole is inversely proportional, related to the mass of the black hole. So the smaller the black hole, the faster it evaporates. So
that makes sense.
let us pretend that little Jackie is a black hole.
Little Jackie, little Captain Jack Sparrow, Jackie.
Captain Jack Sparrow, Jackie.
Aw, Jackie.
So, Jack weighs about 35
this is
pounds.
why you were asking me the animal.
Yes.
I knew you were asking me the animal's weights for this episode. I had a feeling.
So Jack weighs about 35 pounds. That
33,
is
well, yeah.
15.9. It was just easier to do
Right, it's fine.
15.9 kilograms for everybody else in the world. Jackie lived forever. Yes.
Jackie
But
will always live forever.
so is sending out this the Jackie black hole
Jackie particles.
is sending out all these particles. He would his life as a black hole would be 5.925 times 10 to the minus 21 seconds.
Oh no!
So real short. However, though, he has a temperature of 7.7 billion trillion degrees Kelvin. He is hot.
Hot dog.
He is hot. The luminosity is 1.4 trillion 100-watt light bulbs. So he is shining bright. He is shining bright.
Like a diamond.
Like a diamond, yes.
That was
so
a random Rihanna reference.
I'm going to skip a few. I'm going to skip a few that I have in my notes.
Okay, because yeah.
And so there is an asteroid called 6489 Galevko.
Sure.
It is 2.1 times 10 to the 11 kilograms. It is.
Okay.
It has a radius, a diameter of about 300 meters. And so,
did you Americanize that for me?
350
yards.
Oh, opposite.
350 times 3, whatever that is, 1,050 feet.
Okay.
So big. It has a life of 13.8 billion years.
Well, that's reasonable.
So these are the primordial black holes that would be evaporating right now.
Right now.
if they were created
Whoa.
right after.
Wow.
Yeah.
So black holes. Wow.
Whoa.
How many
Yeah.
black holes have evaporated?
And how many are going like, oh my god.
How
I
many,
have questions.
how
That's a
many
good question,
evaporating
Liz.
right now?
Two. I have like a couple just some
How
more
many are
quick things to say.
about to evaporate?
Oh, a lot.
Is our universe filled with black holes? Are
They
there
are.
black holes
Dying
everywhere?
black hole. Oh, we had black hole
Yes.
graveyard?
So
Do they leave
there's an
anything
estimate.
behind? What happens after they evaporate? Is there no evidence?
There-
Do they leave
there-
anything? Is there a little
they-
memorial marker?
They leave in a blaze of glory of gamma rays.
So just
Yeah,
a gamma ray burst?
maybe. But they would have to have probably a very specific signature. Now, there's an estimate. There's an estimate that there are 1,000 primordial black holes
Only?
inside of the Milky Way.
Oh. Only the Milky Way.
Zipping around our galaxy.
There is
Nothing there. There's something.
that is one estimate. There is another estimate that right now there is probably a primordial black hole somewhere in the solar system. But one of the
I think it's in the White
coolest,
House.
and this is how I'm
If
going to end the
only.
show. One of the coolest things that I read about, hey, this is a cool way. This is a way in which you can look for a primordial black hole.
Oh, wait, just anybody?
And it involves, I'm gonna say a geologist named Anne, because all of you should be reading Red Mars. And she's the geologist in Red Mars. Look at rocks. If you have a hole that is a straight line through a rock, it might be, not probably,
What?
but it might be from a primordial black
That
hole.
just what
that
would
has
pass
gone
through
through.
the fucking earth?
Yes.
What?
And with that, everybody, I
What?
hope you enjoyed our show on primordial black holes. Join us in 2 weeks where we are talking about High in the Sky for May. But join us here in a few moments where we talk about Artemis in the Hangover.
I think the next episode is going to be watching us scoop our brains back into our heads, like ice cream, scooping up, putting it back into the skull.
You mean,
Cheers, everybody. We'll see you in 2 weeks.
okay. Bye.
Bye.
We'll
We'll
be
be right back.
Bye.
Join us for the Hangover in a couple minutes. We're going to take a little break. Cheers. Bye.
Oh no! Oh no!
What?
I did the wrong button.
What
I
button
think they
did
can
you do?
still hear me.
We have some breaking news.
Wait, hold on.
Oh.
Hold on. I fucking didn't press the right button because my brain is still fucked up from the main episode, which is Primordial Black Holes. So check it out if you haven't yet. And Brandon has some breaking news.
I had the black hole hit my backyard, right through a tree, and it fell onto my shed. So a black hole, act of God apparently, is now on my shed. Thanks for that.
Yay. Thanks, Black Holes. Luckily, he's fronting.
I love that episode.
That was great.
It was fun.
Okay,
yeah.
so if you're just watching The Hangover on YouTube and you haven't seen the main episode from this, what we did, Primordial Black Holes, check it out. It is mindfuck a little bit. But fun and physics and fun and physics and lots of physics and Big Bang.
And fun.
And fun. But also, I can't look at rocks the same way anymore. I always love geology and had appreciation for geology. I like when we're driving and we see like the strata on rocks and whatever. And now, are you looking at the coaster that I made for?
Yes, I am. I'm looking for holes.
But it's got to go straight through.
Yeah, I was looking.
Yeah, well, if you see a rock with a hole straight through it, I'm immediately gonna be like black hole rock. Black hole rock, and I will start collecting them.
That is just one way. And it was just a thought.
How do we hypothesize that we think there might be one primordial black hole in our solar system? Like, what does that come from?
I'm not entirely sure where they got the number.
Is it odds? Just the odds are there's probably one.
Well, they said there's 1,000. The number you had was 1,000 in the Milky Way, right?
Well, what I said was that there was one estimate that said there's like maybe 1,000 in our galaxy. Then there's a whole other thing that was like, hey, we probably have one inside of our solar system, and you know, is it in the center of the sun because the sun's gravity caught it and that type of thing? That's entirely. But also you could have.
Wait.
All right.
Sorry. Go ahead. I'll come back.
You could
have a primordial black hole that is basically like a bullet and just shoots through these objects. Now, these primordial black holes, oh damn it.
They don't know what they're doing.
Right? All right, let me look it up.
This sounds like a lot of officious entanglements. I'm sorry.
Well, Mike's looking that up.
It's like the third.
I know. I'm sorry. Can I promote myself real fast? Can I plug myself? If anybody wants to come out to Oak Ridge, Oregon at the end of May / the second weekend of June,
She is really.
I'm gonna be in a play.
A maze.
And that's one of the lines in it that I say. And so anyway.
Oh, is it really one of the lines? I'm gonna be in a play?
No, the officious
Oh, you say a maze?
The officious entanglements. And that just shows that my 3 years of university were worth it. That's why I say that line.
And not just the tattoo.
Anyway,
before Mike jumps into his thing, first of all, yes, I will be there for a play at some point. If there is a primordial black hole in the center of our sun, apparently, does that mean that we have a black hole sun?
Oh!
Show your tattoo. Show your black hole sun on your rocket tattoo. The tattoo that I am jealous of.
My rocket?
Yeah. Black hole sun.
Oh,
right
that's cool.
On his cool retro rocket.
You know where else had a really cool eclipse that looked like a black hole was Artemis II.
Oh, hey! pulling it in because the Hangover we were going to talk about. We are going to talk about Artemis.
We're going to go back to black holes though for sure.
Yeah. So, all right. So Artemis II. It launched. It happened. It was real. It was not a fucking April Fool's joke.
No. And
Mike was watching these videos on YouTube of he watches people that debunk these like people that say bullshit trying to debunk shit that's happened.
Yeah, they basically like the videos I like are the ones that like will other than the political ones are the ones that debunk flat Earth.
Yeah,
because
Mr. Frodo, we will freely. Oh, Frodo! Hi, Mr. Frodo. We will freely promote like Simon Dan as one of them.
Yeah,
and Creaky Blinders. We'll promote them. They don't know anything. They don't know we exist. But and there was one he was watching, and I happened to be like in the vicinity, because I live here as well, and and he was showing a video of some dude that had basically put up a generated AI image that showed the Artemis astronauts against a green screen.
Oh,
and
so
trying
bad.
to show that they were against a green screen, and I was like, oh my god, it doesn't even make sense, this AI image, because it just the way. Anyway, it's bullshit.
It was real.
It was bullshit.
No, no. The Artemis launch was real.
The Artemis launch was real. Here's the crew from the Artemis launch. Please name them, because I really tried to memorize their names, and then I just my brain now. The drink is really hitting me. Chrissy,
we got Jeremy, we got Victor, we got Chrissy.
Victor's a pilot. He's up front there. These two look like twins.
They do look.
These two white dudes.
Jeremy's Canadian.
Well, they look like twins. Anyway, here's the crew. They really went, and it was a thing that they did. God, controlling this fucking stream deck is gonna be difficult. So okay, Artemis II. So I was thinking about this, and I would say that millennials, elder millennials, and younger millennials that Brandon falls into, and yeah,
What did you just call me?
I said elder millennials, and I said other younger.
Oh, I thought you called me an elder millennial.
No.
I was about to get up in arms.
What?
I am peak millennial.
No. I am your elder. I'm your elder millennial. How dare you? I am borderline Gen X.
You want to know what the official name is?
No, it's geriatric millennial. Thank you. And yes, my back definitely feels like that, and my knees as well. Are starting to.
Can I get the names real quick?
Yes, please.
Commander Reed Wiseman, NASA. Victor Glover.
You don't need to say NASA.
The pilot is no, you have to.
Yeah.
Pilot is Victor Glover, also of NASA. Mission Specialist 1, Christina Koch, also from NASA. Mission Specialist 2, Jeremy Hansen from Canadian Space Agency.
Yeah.
CSA.
Which
Canada. I think how you can describe this and how it makes you feel is this morning. Hold on. No.
I was in the middle of mine though.
Oh, go ahead.
Okay. It's just that I would say the millennials, including the elder millennials that feel like we're more Gen X than we are millennial, and Gen Z, and I would say I don't know how old Gen Alpha is now, if they can even if they have any cognizant of the world around them.
Is that what Susanna is?
No, Susanna's Gen Z.
No, she's. Oh, is she? Yeah. Okay.
I'm pretty sure she's a younger Gen Z. Susanna, you can comment on this. But this is our Apollo. This is our Apollo mission to the moon. This is our first whatever Apollo moon flyby mission. And so it is like historic and important. And there's a woman involved. So even better than Apollo, because there's a woman there. Yes, Dad, you should know this. You're Gen Z.
I can't keep up with all the letters.
I know. Well,
I know that you're like.
Tell that to the LGBTQ plus IA plus community. You can't keep up with all the letters.
All right.
But yeah, no, this is a historic moment, and the fact that like Brandon and I, to be fair, you were just born when Apollo 11.
I was a couple days.
You were just born, so
I was 2. I was 0 plus 2.
Yeah, so you weren't totally cognizant of it happening.
I was just like, "Where's my meal?"
Yeah, but this is our this is our moon mission of people going to the moon.
I think one of the many reasons why I was jaded at this milestone, as opposed to being full of wonder and awe and inspiration, being motivated to do things at these sites. One of the reasons, who can go the other ones, but we've had Cassini, we've had James Webb, Hubble, we've had all these missions go out to these other worlds in the universe and explore and get these images back. Whereas in 1968 with Apollo 8, that was like the first one you were getting back. Like this was the first picture of Earth you were essentially seeing from beyond the moon. Whereas now we're so filled with knowledge of what we look like from Mars, from Saturn, from beyond, that it's not as mind blowing because we have essentially been there.
No,
Okay,
I
well, that
think
being-
it is. Hold on. I do want to say my thing. I do think it is mind blowing because there was a comment this morning that I think sums it up, and for me, and it was, I had like, all right, I'm done with the notes for primordial black holes. I'm going to, and so I walk in and Liz is watching a YouTube video on this, and she goes, "It gets me. It got me."
Well, yeah, it's partially just hormones.
No,
but
I think
I cry a lot easier now at things, but
how can you not look at this picture
okay,
that we have here?
This is the today. So you had the Earthrise image of the 1960s, which the video on YouTube
Okay,
I watched.
hold on. I still didn't get to finish what I wanted to say, which is I think by you saying that it gets me, it makes me tear up. I think that sums it up. Because we have never met these astronauts in our entire life,
and we never will.
Most
likely.
And if we are, oh God, we're so lucky. But
I mean, brains has astronauts.
We're riding with them, and we see these sites that we see here, where we have this Earthrise over the moon, and how do you not get emotional at that?
Yeah.
How do you not look just at the pictures of the Earth and the moon?
Yeah.
And not just be moved by it?
And the fact that this image right here, this new Earthrise image, was taken by a human on this side of the moon, on the far side of the moon. And so the video that I watched was a Hank Green video talking about like the pictures that the Artemis astronauts took. So follow Hank Green, look at Hank Green's shit. He's cool. He does good stuff. Of course. And so he was talking about in the video, actually, he showed some clips of or like an animation and the audio from the Apollo mission that took the Earthrise image of the moon, and where they were totally not prepared for Earthrise. And you hear like they had like a black and white film, and it was who's the guy that starts with an A?
Bill Anders.
He was like, quick, get me the color. Give me the I need it quick. And they actually had to go to another window because he lost the shot and had to go to another window once they got the color to actually capture the Earthrise, because they weren't prepared for what they were actually going to see there. Whereas now we were more prepared for kind of like what we could possibly see when we were there. And obviously the camera technology wasn't film camera technology and digital camera, so they could capture it. But also this perspective isn't necessarily what you would see if you were on the moon. The Earth was much smaller and everything, but this
obviously has to be off the moon.
And the perspective is actually different from the perspective of where the capsule was in relation to the moon, and so it's been actually flipped on its side to give that kind of Earthrise effect. But this is a real image, and first of all, absolutely gorgeous. But this is like this is people that are seeing the Earth from their perspective in the capsule, rising, setting, whatever, over the limb of the far side of the moon, which we can see. These are human beings that visually, with their eyes, in person, saw all these craters. And everybody, to quote Sagan, and everybody that's ever lived on the Earth, right there in this shot, and it's absolutely
except for 4 people. Hold on. Don't cut from it. Don't cut from it, because you bring up Sagan. That actually, we watched this whole thing live when they did the fly around, and they actually got this picture right here. And it was the communications director or whoever, she basically like quoted Sagan without quoting Sagan, and she was like, and she was like, everybody that you know that has ever been on Earth is right there in that shot,
Unless
except for 4 people.
So on the other side of the Earth. But also,
what?
Unless they're on the other side. But also, here's the capsule with the moon and with the Earth in one shot right here.
That's a good one.
Outside of
yeah.
So there's everybody except for everybody and as Hank Green
4
said,
people. Everybody but 4 people.
Everybody that they're in there.
So
right
everyone
there.
but like one person.
No,
that's the capsule. That's the Intrepid.
That's the bottom of the capsule, right?
That's where the astronauts are.
The capsule's down there.
The astronauts are in there. So this is an outside camera, right here of basically the Earth, the Moon, and the what is it? Inspire.
It was
Intrepid.
Intrepid.
Yeah.
In the Intrepid capsule right there. I mean, absolutely fucking beautiful. So let's kind of look at I went out of order with this just based on what you were seeing with how I had it planned. But let's take a look at this image right here. Here's the Earth as the astronauts were leaving home.
Integrity.
I can't get them straight. You have, all the shit on Mars.
Yep.
And then
okay, can we say that this is processed? That this is
not processed.
No, but like there's another one that's just like this. That flat earthers are like, oh,
no, this is the
image. Different.
This is the image. See how all it's grainy and everything?
Yeah.
This is not, and I don't know if it's showing up grainy in the feed. Just on our monitor, it shows up pretty grainy, but on my other computer monitor, it doesn't. So when you look at this image, you can actually see the aurora, the greenish in the north and south poles,
Venus.
And the Earth is actually flipped to our normal perspective of the Earth on how we would actually look at the Earth on a map. Venus in the lower, that bright dot in the lower right is Venus, but you can also see that thin line of atmosphere all the way around the Earth. And what I learned watching the Hank Green video is that is called the sodium line. So that is sodium. That's sodium that is in the upper reaches of the atmosphere.
Oh, that's cool.
Yeah. So it just shows you like how thin our fucking atmosphere is, and
that
on
is
this globe of the
all
Earth.
That separates us between us and space.
Yeah, that's all that separates us and Venus in this image. I mean, and then you could see in the center there's actually an artifact, a reflection from the light inside the capsule that was captured there.
Oh, that's what that is. Okay.
By the way, lower left there, that is Africa. That is the northern part of Africa.
Northern part of Africa because it's upside down. To what you would normally see on a map. And you can see
Spain.
that it's round. It's round.
It's not flat. It's not flat. The Earth is not flat.
This image also phenomenal, showing from the window of inside
that's a good one.
The capsule, the Earth, and just looking at the window and all of our man-made shit. And then here's the Earth and what you would see basically if you're looking out the image.
One of my favorite things of the Apollo missions was like the 60mm camera they had, and they just take kind of pictures of the capsule themselves, and then in the background you see the moon or you see the Earth. So that's exactly what this is.
I do want to say one thing, just real quick. If you want to get the actual pictures, please go to NASA.
Yes.
Do not go to Facebook.
There's a lot of AI bullshit on Facebook and social media. Go to NASA's
Go
website.
to NASA. NASA's got it. NASA has to release these images.
Yeah, your tax dollars pay for it.
Yes. And so,
was it within 24 hours of the pictures they have to release it? I think it is.
Yeah, something like real fast.
So all of these credit NASA, but also your tax dollars go for it. Here's a peek of the moon and the Earth through a window. This is a beautiful shot. It does look like a little eye. So this is also a beautiful shot.
I love that as the Artemis astronauts got closer to the moon, they got so bright they had to put a T-shirt over the window to block out the lights.
Yes.
All that.
Was it? Didn't NASA suggest that, or was it because there was like back and forth, and they mentioned that where they were talking about how they had to put like the T-shirt and stuff like that.
Yeah.
To block,
because they were about to flip around and they need the eyes to get dark adjusted, and it was so bright they couldn't do that, so they had to block out that light.
And there was a picture I didn't put in here, but they're all wearing eclipse glasses.
Oh yeah, that's that's
Oh, yep, for
Because
that.
of
Same
the
ones we have.
eclipse, because of the same ones that you get for an eclipse. And so this image shows the eclipse, which if they did not launch when they did, so if they launched earlier when they were initially scheduled to, or if they launched after April 1st, they would not have gotten this shot, this view of the moon eclipsing the sun. And so this is the corona of the sun that we're seeing behind the Earth that is 93 million miles away with the sun. And yes, Mikey's raising his hand. No one can see you because the image
Nobody
is
can
up.
see me. But what I think is really cool about this is the sun is behind the moon.
Oh, Earthshine.
Earthshine.
Yes.
Earthshine.
So you can see that part of the left side of the moon is illuminated. That is light reflected from the Earth. The sunlight on the Earth reflected onto the moon.
Which is why you can't have vampires.
Yeah.
And also, they broke Apollo 13's record of being the furthest humans away from planet Earth. And so the moon wasn't like huge like it was with Apollo 8 or any Apollos, but it was like a basketball held at arm's length.
Yeah, because they were.
That's how big it was. Yeah,
far enough away to see the whole thing. And then also in this image, on kind of the lower right, there's actually 3 planets that you can see. It's oh god, our dogs are going crazy right now. But one of them is Mars. I think Saturn might be the lowest one on the right. And then one of them is Mars and
Venus?
then Venus.
Okay,
It's
I'm gonna
Venus,
guess.
Mars.
I'm gonna guess Venus is the far right because it's brighter. Actually, the one
No, I
closest
think
to the moon is
Venus
pretty
closest
fucking
to
bright.
the moon is Venus,
Yeah.
and then it's
Yeah.
Mars, and then it's Saturn. I don't know where
That makes sense.
Jupiter is, but you can see how they're in line, so you can see basically the plane of the solar system, the ecliptic of the solar system, the Earth being obviously way off to the left, causing that Earth shine. And what's really great about this is that you can see stars in it, which normally with the exposure of a camera, it's not long enough to see stars. So you'll see other images of the moon and Earth where there aren't stars around it. And in here you can see the stars because they had a long enough exposure, or they had the ISO way up to capture.
And that's how you know the Apollo landings were fake, because you can't see the stars in the sky.
Yeah, exactly.
Oh my god! One of the videos I watched today was all about that, and the guy was like, the guy who's debunking all this is like, you obviously don't know how fucking cameras work.
Yeah. Here's another image from the eclipse of Venus here on the left hand side, and then a little camera artifact that's in between the moon and Venus, and then. Actually, apparently they're kind of looking into if this is corona that they're seeing, this light from behind the moon, or if it's zodiacal light, or a mix of corona and zodiacal light.
So what is zodiacal light?
So there's still,
It is the dust of the atmosphere. I mean, the dust of the solar system. So in the plane of the solar system, you have a lot of dust, and that is the dust that the zodiacal light is the sun illuminating that dust, in the plane of the solar system.
Nice. So they're still looking at this and trying to analyze exactly what they're seeing here as far as that light behind the moon. So it is of scientific value.
Yeah, and so you would with zodiacal light, you would expect to find most of that glow in the same plane as the moon and Venus which is kind of
which is
seeing.
What's happening. So it could be a mix of both, and it could be one or the other. So, I mean, those are some of the pictures that I thought were just
beautiful,
phenomenal,
awe-inspiring,
amazing. And what's great about, I mean, we have telescopes that go around the moon, so we know what all sides of the moon look like. And we can study them and whatever. There's, from the near side to the far side, not called the dark side. It does see sunlight. It just orbits the Earth at the same rate that it revolves around the Earth, so we only see the near side of the moon. But to have a physical human perspective of it is something different than just having, a robotic spacecraft take pictures of it.
Oh yeah.
And the fact that this was just an exploratory mission of testing equipment. Basically, this was testing our ability to get back to the moon, using this technology from the SLS and the Orion capsule and what have you. So the ultimate goal is to actually have human beings walk on the moon again, and eventually establish, a permanent base on the moon. And the moon is our segue into Mars territory.
I will only say this briefly, and then we'll move on from it.
Okay.
But if you would like this to continue, do not forget to vote, because the White House has given a $6 billion deduction in NASA's budget for the next fiscal year.
Yeah. Which NASA barely gets anything as it is.
All right. Yeah. I am not defending the orange piece of shit in any kind of way. So please do not take it that way.
God,
please vote.
That would be the end of the world if you started defending
right.
that motherfucker.
Because this is America shit where you can like raise a flag. This Artemis stuff though is not affected, but everything else is affected in this budget cut of NASA. But Artemis and like manned missions.
I wouldn't even say that Artemis is not affected, because of course if you're working on the Artemis mission in NASA and you're seeing everyone around you be affected by being laid off, by having budget cuts, you're thinking the same thing, and you're going to secure your future and get a job in the private industry. So yes, Artemis is still being impacted 100 million %.
Definitely vote smart. Don't vote for this bullshit. But anyway, the good news, call your representatives, because all this shit that Trump says is just him saying stuff. Yeah. He's not setting a budget. Only Congress can set the budget, because that is, Constitution 101. All you
not that matters anymore.
Yeah, that's true. Anyway, Brandon.
Yes.
When is it that we want to land actual people on the moon?
I think if we stick to the timeline, I think it's late 2028, if I recall correctly.
See, yeah, I was thinking 2028 as well. Mm-hmm. So,
and there's a go ahead.
No, I was just gonna say, like, my mom and I had, and Liz, you were in it as well, because your family chat, but with my parents, well, with my mom, my dad doesn't do, but anyway, we're having this conversation, and my mom was talking about, hey, in 1969, we were there for Apollo 11 and all this kind of stuff. And she was talking about how amazing this is. And Liz and I were like, this is phenomenal. Just going to the moon, the pictures that we're seeing in real time with the flyby. And you're seeing all this in real fucking time with the astronauts. Maybe like a second delay, whatever, but you're getting all this kind of stuff. And my mom was like, my mom is going to be 82 this year. And she was like, and I was like, well, in 2 years, the plan is to have astronauts, walking on the moon. And she was like, well, you guys are going to be able to see it, with the implication that she's not. And I'm like, no, you're going to be, this is just 2 years away. Mm-hmm. This is, and even like, if you get the nationalism out of the way, China's going to do it too. Mm-hmm. It's not just anytime that we can get
any person,
humanity on the moon or wherever, it inspires people. All right, Brandon, take it away.
So I'm going to go back to what I was talking about earlier about being jaded about the pictures. I don't think I was necessarily jaded because we've been there. We've seen these images of the universe, these planets. We've sent crafts all over to moons and other planets. I think the big difference for me personally is that in 1968, going around the moon, there was a promise of a better future. There was a promise of exploration, of landing, of being there for the first time, of exploring. I do not feel that promise exists today, because in the 60s, I'm going to keep going for a second. In the 60s, they still have plans of, going to Mars, doing these exciting things. And society, at least this country, was behind it. We thought that was going to happen. You can see that in science fiction. Whereas today, due to various different climates, political, otherwise, we do not have that promise. We do not have the, for sure, we are going to go on and improve and keep going. It feels different. Mike has a thought. Liz has a thought.
One, we lost the plot, as apparently everybody says now. Two, do you think things would have been slightly different if Kennedy was not assassinated.
All right. Okay. Hold.
That's a big question.
Hold on. Which Kennedy? Because I think
JFK.
both of these.
The main one that was
The
president.
wrong Kennedy
No.
died, guys.
No. All right. 1968. You had.
I mean, there was the Cold War bullshit. in space
No.
race.
Okay. Hold on.
I know
hold
where
on.
you're going with this, Mike.
No.
Keep going.
Hold on. Just please, just let me.
Okay, go.
Wow. All right.
Sorry.
1968. Robert Kennedy, Martin Luther King assassinated. 1969. You walk on the moon. So yes, there is that. What you were talking about, the whole promise of, However, what it is today is, yes, we've lost a plot or whatever it is that you said, and other things, but this reminds us of what the future could be. And so in 1969, when you're walking on the moon, it reminds you, it shows you, hey, this is what it could be. Vietnam is raging at this point. You've had two major people in American politics and society brutally assassinated the year before. And it kind of reorients people. And we kind of have the same thing going on today. You have discord and turmoil in the Middle East. You have political craziness in the U.S. itself. And this reminds you that the universe is bigger, that it's not just this bullshit that's going on. And hopefully, I don't know. I'm being idealistic. And I hope it reorients people to getting people to the moon and beyond, and looking at how the universe operates, and just I would hope that MAGA can look at some of these pictures and just go, God damn it, that's fucking beautiful. Oh,
and as
I can hope.
I have no hope for that. Absolutely.
It's a fool's hope.
Those people are
is a
too far
fool's
fucking
hope.
gone.
But a hope nonetheless.
Those people,
do not trust the hope. He's forsaken these lands.
Those people are too far gone. They would vote for fucking Putin before they would vote for anything.
Have fun at the concert, Jack. That sounds great, because I'm going to have a second. And as we saw in 1969, society was so inspired by NASA that we decided to continue funding it and to continue our reach outward into the solar system.
No, you cannot do that. You cannot do that.
We have to have historic analogies.
There were so many people. Do not equate politicians with all the people that were inspired by this. That people that how many people are at JPL or at NASA or that have gone into some sort of STEM discipline because we sent 12 people to walk on the moon, 18 people.
I can go ask them because they don't have jobs anymore.
No, don't equate politicians. This is inspiring.
No,
people.
yes, and that's something why I'm jaded about this.
No, I completely get that. Those
people that are inspired need to go into fucking politics and get fucking and promote fucking NASA and the shit that matters.
What we need to do is we need to call those politicians. We collectively, but I
politicians were around when the Apollo missions happened,
and it's very tough.
Most of the politicians we have today
were
around during the Apollo.
And it's very tough to get a response from.
Yeah, exactly. They were all around during the Apollo missions. They don't fucking go.
And it's tough to get a response from these politicians when they can't talk because Trump's dick is in their mouth.
Yeah.
I think
black holes, people. Black holes.
All right, hold on.
I'm sorry, I went way off the edge there.
Hold on.
I approve of this.
I think that you cannot hold politicians, and you see, I mean, that's not fair because politicians the politicians are the Republican Party. They are so beholden to Trump. They're so beholden to 30% of the electorate, the MAGA people, that I think to say that, because in 1969, where are we today? Because 1969, the funding dried up and all that kind of stuff. I think that does a disservice to all the people that were inspired by that. Whether they have jobs or not now is irrelevant. They were still inspired by it. How many people went into STEM because humanity walked on the moon? How many people how many people wrote science fiction, which then inspires people?
And I am completely agreeing with you. I think my response comes from a place of anger, of malice. I'm so mad.
Find their jobs, then what's the fucking point?
And I completely agree with Mike. That inspiration fucking matters. It matters. The amount of science we got from Artemis II is not that huge, but the amount of inspiration and motivation we can give to people around the globe, that is the reason why.
It depends on the politicians of today, who's elected and who people vote for, to then listen to their constituents' inspiration and what they want, to then fund NASA and to fund these things to continue.
So let me ask you a question. Then why do this? Why go to the moon? If this is such if this is such a nihilistic philosophy, why go to the moon?
I have two answers.
Why have podcasts that talk about going to the moon?
I'm going.
Point is.
No. I am going to give a nihilistic answer. I'm going to give a completely jaded answer first, and then I'll give my real answer. So the jaded answer, and I'm going to take a drink for this one because this is going to hurt my little soul.
Oh no! I'll drink.
My jaded answer, and I do not believe this in my soul, but is political momentum. So the response that NASA gets in general from a variety of people from certain segments is that it's a jobs program. If you were to cancel the SLS, I know, Mike, I'm with you. If you cancel the SLS, if you cancel Artemis or Orion, you lose tens of thousands of jobs. And important people in Congress will then lose their jobs because the constituents no longer have jobs. And that is a reason, and I love the SLS, that is a strong reason why the SLS is still in production today, is for the economy, quite frankly. Mm-hmm. Now, in my heart of hearts, I do not believe that is the case, but in practical reasoning, that's a huge case. It's political momentum. We've had these programs that are going on for the last 25 years. If you cancel them, you lose jobs, you lose momentum in economies and companies. Lobbyists are going to dry up and no longer fund your campaigns. It's a huge region, and I hate it. But unfortunately, that is part of the reality we have to contend with. Mm-hmm. Now, within my soul, of course, this is fucking worth it for any 1,016 reasons. The inspiration is seeing the Earth rise, to seeing everyone and every that has ever existed in a single picture. That is the reason we do it.
The eventual, death of the sun, and we gotta go somewhere because the Earth is going to be eventually fucked in about 2.5 billion years.
But unfortunately, reality isn't necessarily, I don't know what to say, comforting.
And our science communication has never been great in this country. Our science communication and that whole level of understanding of the importance of space exploration and what actually it gives its ROI.
Did you know that the Navy, the Marines, they can all advertise? NASA is forbidden by law to advertise. They are forbidden by a law of Congress. They cannot advertise themselves.
What? Why?
Yeah.
But the Navy.
Fuck if I know. Yeah, they can put advertisements for recruiting. NASA cannot.
What?
By law.
What? That makes no sense.
Okay.
Whatsoever.
I apologize, Mike.
No, I just feel like, that it doesn't matter. It doesn't matter. All right, go on. It doesn't matter.
I think it does matter. If I look behind what I'm looking at, I have a science fiction photo of somebody living on Titan, looking at planet. I have all these science fiction books behind me.
Mhm.
I believe in the future. I believe in inspiration. My soul would die if Artemis was not happening. So yes, of course, that is the reason why we do this. It's for inspiration, and it matters so much.
Why can't we just take a moment to enjoy the inspiration? Why do we have to take what was a phenomenal goddamn fucking week?
I see.
And then just jade the fuck out of it. I mean,
I see.
You know, we had a moment where, for once, I guarantee you, probably 90% of the world was watching this stuff and going, this is goddamn cool. And, you know, just leave all the politics aside, you know, just the whole, America first or whatever.
And considering our podcast, considering the people listen, we are here to inspire. We are here to invoke imagination. And here I came and shit on all of it. I see your point.
You know, it's just like, it was what a 10 days that was. And for once, for a moment, for 2 moments, because I mean, I did look between, I'm going to say 3 moments. During the launch, I watched. During the flyby, I watched. During the splashdown, I watched. And for the other goddamn 8 days, 9 days, 10 days, whatever, I checked in. What are they doing? And it was inspiring. And I don't think we should underestimate how important that is. There's going to be people that were inspired by this.
Oh, for sure.
And they are going to go. They're going to go find a STEM career. It doesn't mean that they're going to go end up working at JPL or wherever. That they're going to go into a STEAM career that they probably may not have thought about. There's going to be somebody that was so inspired by this that they're going to reach out to their congressman and they're going to be like, hey, you need to fund NASA. You know, don't take $6.5 billion from NASA's budget. Fund them, and not only fund them that $6.5 billion that Trump wants to take from their budget. Fund them more. Fund them so that we're not only going to the moon, whether it's a flyby or eventually that we land on the moon, because we will in a couple of years. This is just a stepping stone. But we look out into the universe and we better understand the universe that we live in, the solar system that we live in. But let's also look inward and let's look at the Earth, because Trump has killed that budget as well. Not only now, but just a year ago.
I was so angry that our inspiration and dreams are under attack that I took the platform to events as opposed to celebrating.
You know what? You have that right to be angry that, you know, it is that is being taken from us. Generally is being taken from us. But for these 10 days, let's enjoy this moment.
Guys,
group hug.
Okay, but can we also think about, for these past 10 days, there's 4, how many of them were 4 of them? They all had to poop in front of each other.
Well, they had a curtain, and the toilet did break.
That's true, but the woman fixed it immediately, pretty much. She fixed it pretty fucking fast.
But then there was also a weird smell.
No, it was that there was a line that was frozen, and then I think the sun took care of it.
Oh.
But at the end of the day,
that black hole sun took care of it?
Yeah, but at the end of the day, we all gotta poop we gotta shit in front of each other. It's shit all the way down. We all gotta poop. Everybody poops. Everybody poops. In space, on Earth, everybody poops.
Everybody poops.
We're all reduced to poop at the end of the day.
We're all pieces of shit at the end of the day.
We're all pieces of shit at the end of the day.
From here to there.
You know?
It's in the process from here to there.
And that brings us together. And that poop should bring us together as a species on this entire planet.
Take us home, Liz.
Everybody poops.
Join us in 2 weeks.
Where we get high in the sky
Audio's
for
gone.
May of 2026.
I don't even want to talk about it. Why is it May already?
I don't know why it's May, because check out our episode on time.
It's
That'll
gonna
tell
be
you why
May.
it's May. It's gonna be May. It's almost summer. Not summer yet, but it's almost summer. But it's mid spring. Height
Almost.
of spring.
We're like 2 months away.
We're 2 months away from summer. Lots of things will be happening in
Lots
that time.
of things we have.
So many
Oh my
things.
god, are they getting married on summer?
No, it's before summer.
No, June 20th, right?
It's summer. It is summer. When summer happens, we will be at a wedding in summer. But before summer, everybody on this planet will poop multiple times.
Oh
Hopefully.
shit.
Hopefully.
Unless you've got a problem.
Oh no, it's the 21st. They get married one day before.
One day before summer, so not
Wow.
not a summer wedding, technically.
I mean,
No, it's a spring, end of spring, late spring.
But as my mom says in chat, the space program is such a good thing for humanity on so many levels. In a lot of ways, it was pointed out during those 10 days. And yes, It is. In fact, Google Return of Investment NASA, and you will be guided to some information on everything that you use in your daily life that comes from space exploration, human or otherwise. And why it is important to invest in the ultimate final frontier that we have, which is the rest of the universe beyond the Earth.
Right?
And
Beyond that sodium line?
Beyond that sodium line.
Ooh,
Beyond that
nice.
thin fucking sodium line.
Are you looking for
That is the fucking Earth. Our thin atmosphere that contains everybody within it protects us from all the harsh cosmic rays, from stars exploding in the universe, the radiation from the sun.
Go back to the moon and the Earth.
This one right here.
And do not come back to us.
Do not come back. You want to end the show
I
on
want
this
to
image
end
right
with
here?
this picture.
All right.
Consider again that pale blue dot we've been talking about.
Exactly.
On it, everyone you know, everyone you love, everyone you've ever heard of, lived out their lives on that pale blue dot. Every hunter and forager, every king and queen, every criminal and defense attorney. I don't know it
Make
line
it up
by
as you
line.
go.
Every defense attorney.
Wow.
Wow, bring in the dredges of. All right,
That is everybody that ever is and ever has
Except for
been
4 people.
right there. And at the end of the day, to be human, from Wildixia, to be human is to poop. Thanks for joining us, everyone. We'll see you next time on Cosmos to Cosmos. Follow us on all the things.
Cheers.
Cheers.
See you in 2 weeks.
Pie
in the sky, May.
Keep looking up. out
Whatever
there
2 weeks is from
and
now.
Imagine the universe. Bye, everybody.